Hey guys, these are our notes on synthetic divisions. Hopefully, it won't take too long. It'll probably be 2 videos, but not a ton more than that. So we learned long division last time, and that's kind of a pain. And you don't normally need to do it necessarily, but sometimes you have to. But if there's a certain, if you're dividing by whatever kind of polynomial this is, if you're dividing it by something that looks like this, and by looks like this is your divisor. And if the divisor looks like x minus a, where a is some number, whatever, it doesn't matter what it is, some number. If this is what the divisor looks like, you can do synthetic division. And what synthetic division is it's like a trick with dividing where you don't have to actually do the division. This guy years ago, like in like the 1700s or the 1600s or something, realized you're just moving coefficients around. So he's like, why don't we take away the x's and it'll be easier. So here's what you do. You're gonna do, right, you're gonna draw a little, this is like a little box. And inside the box, you're gonna put the number that's sitting here. And that number is 2. And the number in here is not -2 because we think of this expression here as being x minus a. And so x minus a is 2, it's not -2. If a was -2, x minus a would be x plus 2. So whenever this says x minus 2, you write 2 there. If this said x plus 2, you write -2 there. And then in a line horizontally from the box, you're going to write the coefficients of all of these terms here. So the coefficient is the number in front of it. So the coefficient of x cubed is 1 because there's no number, so it's a 1. The coefficient of x squared is 6. The coefficient of x is -1. The coefficient of the constant term is -30. Okay, and it's really important that these things, well, if for this to work, the terms in this polynomial have to be in descending order. It has to go from the largest power of x to the smallest power of x, which in this case is 0. X, this is third power, second power, first power, this is 0 power. But like if this thing is if this thing is mixed up, you got to rearrange it before you write these coefficients here. Then I'm going to leave a little space here, and I write a line. And I put a little line here too. You'll see why in a second. So here's the trick for synthetic division. The first thing you do is you bring this number down, 1. Then you're going to multiply this 2 by this 1. And whatever that product is, you put it right here. 2 times 1 is 2. That goes there. Now I'm going to add. 6 plus 2 is 8. Then I multiply. 2 times 8 is 16. Add. -1 plus 16 is 15. 2 times 15 is 30. -30 plus 30 is 0. So basically, you like kind of add to the first. It's really you're adding and multiplying. That's it. Like there's like a 0 here, so it's always 1 plus 0. So I just think of it as bringing down the 1. But really, it's like you add, you get 1, multiply, and you get 2. Add, and you get 8. Multiply, and you get 16. Add, and you get 15. Multiply, and you get 30, add, and you get 0. So it's like adding, multiplying, repeatedly, over and over again, adding, multiplying over and over again. And what happens here is you get 2 things. This first part here is something that when we're dividing, we would call the quotient. And the thing that's in here is called the remainder. And the way to rewrite this is this. X cubed plus 6x squared minus x minus 30. That's it. Divided by x minus 2. That was I just rewrote the original problem. That equals something. And we're going to turn this 1, 8, 15 down here back into a polynomial. The same way we looked at the coefficient here was 1 and we wrote a 1. We're going to do the opposite with these. It's a little trickier here because you need to make sure that you're putting the right x next to it, and it might not be clear at first which one that is. So I recommend maybe at the beginning, until you know what you're doing, you start from the right and go left. So what I mean is the last number here, -30, is just the same as that one. So this is going to be like the constant term in my quotient. So it's going to be like plus 15. right? Like this has no x's in it, and that has no x's, and then the next one has one x, that has one x, and then 6x squared and 6x squared. So it's like 0 x's, 1x, 2 x's, 3 x's. Same way, 0 x's, 1x, 2 x's. So 1x with the 8 and 2 x's with the 1. So what that means is this equals x squared plus 8x minus 15. And then there's no remainder, so I don't have to do anything else here. But it turns out that x cubed plus 6x squared minus x minus 30 over x minus 2 gives me this. Another way to write this, which we're going to talk about later, is this. That says minus, and it should say plus. So basically, this is like a division fact. If this divided by this equals that, then multiplying these two things together must give me the thing on top. It's basically, I'm saying like, if 15 divided by 3 equals 5, then 5 times 3 equals 15. It's like a, right? I think we call those division facts or multiplication facts. That's all I'm doing here. If I divide these and I get this one, then multiplying these two must give me the one on top. So the reason this is important is because I can factor this thing now in our kind of our trinomial way. And being able to factor this thing, this original polynomial, into just linear factors is pretty important. So we'll talk more about this in the next video. It's our first example. There's a number of other examples. We're going to do this one next. I'm going to do it in the next video. Oh, wait, that's the same problem. Okay, I'm going to do this one in the next video. It has some different tricks to it, but stay tuned.